Okay, so this is going to be a quick video to recap inverses and then to also show you how to prove inverses. So when we're talking inverse functions in math, basically you're talking y becomes x and x becomes y. So one of the main things that your teacher is going to tell you is that to find any inverse, you just have to switch the x and the y. Now, if it is a graph, you could pick a point, switch the x and y, and then regraph the point. And what you're finding there is like an inverse coordinate. You could also graphically, a lot of people like to think of it as a reflection across the line y equals x. Now, what this means, everybody, is y equals x looks like this. It's got a slope of 1 and it crosses through the origin. Excuse me. So that if you had a picture or something, I don't know, maybe I'll draw like a random parabola. Okay. If you have a picture, the inverse picture is when you reflect this graph over this blue line. And what happens when you do that is it ends up kicking it over sort of on its side. But you could always, if you don't like the reflection thing, do what I said in number 1. Take a point and label it. So maybe this is the point like -4, 1. And then you flip the x and the y and it becomes 1, -4. So what you would be finding is like this point, right? Oops. I know that actually looks terrible. -4, 1, 1, -4. Let's try that one instead. That looks a little bit better. Whee! Okay, so that's kind of how this works. 1, -4. Okay, so another part of inverses is having to justify or figure out if a function has an inverse. And so what might happen sometimes is you may ask to prove if f and g are inverses. And you'll be given 2 functions. Now, a proof, they don't want you to just graph it and look at it. They want you to actually use something else that you've learned in math recently, a composition of functions. Okay, so let me go ahead and make up this problem and then I'll show you what I mean. So let's say that f is like 3x plus 2 over 7, okay? And then maybe g is going to be like 7x minus 2 over 3. Okay, so if they give you these functions and they want you to prove if they're inverses, there's this little cool math rule that says that if f of g of x is equal to g of f of x, and they both equal x, that you have found an inverse. Okay, so I'll put a check mark. It means, yay, they're inverses. Now, don't let this confuse you. It's the same thing that, like I said, you've done recently, where when you see f of g of x, what you're supposed to do is take the g function and plug it into the f function and check. And what should happen is it should reduce to an x. So let's see if this works. So g of x is all of this, right? I'm going to take all of this that I circled and plug it into f. Now, where does it get put into f? In the place of x. So what happens is I have 3 parentheses 7x minus 2 over 3. So all of that garbage just went into there, and then I recopy the rest of this. So there was a 3 here, there was a plus 2, and then over 7. Now, I know looking at this, it's a little overwhelming, but just do it a little bit at a time, guys. Check out these 3's. If you have a 3 out front and a 3 on the bottom, those are just going to cancel. So then if I recopy what's left, I have this. Ooh, see what's happening? What's a minus 2 and a plus 2? Gone, gone. They go to 0. And then 7x over 7, well, crap, that's going to reduce too. So it worked. So if I plug in the g to the f, it reduces to an x. Now, what if I go the other way? So let me do this one now. I'll switch colors so you can see me doing it in a different color. Now we're going to take all of f and plug it into g. So now we're going to go the other way. So all of f gets plugged into g instead. So I'm going to have the 7 with all these parentheses. Let me go ahead and just copy all of g first. That might be easier. So here's all of g, and then the f equation is going to take the place of that x. So it's like a substitution. And now let's math it out. Okay, So same thing as before, 7 here and 7 here, gone, gone. And then we have 3x plus 2 minus 2 divided by 3. And then same thing's going to happen. Minus 2 plus 2, make a 0. 3 over 3, well, that's just x. So, yay. So both ways, when we plug them into each other, they simplified to x. And that's what the definition says. So you need to be able to do that kind of a thing on in this chapter. So, all right, cool. So hopefully that's enough of inverses. One last thing, just in case you're sketchy on it. If you have to find your own inverse, find inverse of f of x equals 6x minus 2. Let's say it's like that. Now let's make it harder. Over 5. Okay. If this is the job that you have, step 1 is to switch the x and the y. So you have to switch these two places. So basically that means over here you should no longer see an x. You should just see a y over here. And now this thingy over here is going to be your x, right? Because remember, this is just fancy talk for y. So I've just switched x and y. And now after you've switched x and y, your goal is to get y by itself. So the first step to getting y by itself is to get rid of this denominator. So if you're dividing by 5, the way to change that is to multiply both sides by 5. So you're multiplying it over, and it makes it go away here and here. And then we have 5x equals 6y minus 2. Okay, still trying to get y by itself. So let me add 2 to both sides. And then what's the last step? Well, divide by the 6. And now those are gone. So this would be the inverse. The notation for inverse is a little -1. Or you could say f -1 of x is equal to all of this. Either way, it's a good answer. So that's everything for inverses. Hope that video helped. Thanks.